Hello everyone, I'm Ken Smith with the Bosch Home Comfort Group. We would like to welcome you to the video training series on our Bosch equipment.
And I'm Fred Crick. And today we're going to be working with troubleshooting the board, troubleshooting the components, things like that. So what do we have here between L1 and L2?
At this point, we have 209.
209. So what we're wanting to do is we're wanting to ohm out the compressor. So I'm going to pull the disconnect. You'll notice that the screen will go dark. There's an E5, meaning that we were wanting to run, but we pulled the disconnect. It's E5. That's a protection code. Went dark, but that does not mean that the capacitors have dissipated. So again, like the book and the nomenclature on the back of the panel says, we're going to go to points Paul and Nancy, P and N, and we're looking for 42 DC, less than 42 DC volts.
It's coming down. 32.4.
So actually right now we're less than 42 DC volts, so what we can do is we can unplug the UV and W wires, and we're going to ohm out this GMCC compressor on this Bosch IDS unit. Now this compressor is again a GMCC compressor. We are not looking for a common start and run, but we're looking for 1.5 ohms and less on each one of the terminals, U, V, and W, and all three of those numbers are going to be the same if it's a good compressor.
1.2. 1.2. And 1.2.
So we've ohmed this compressor out.
And ground.
And we go to ground.
Good.
And it is infinity on the ground.
Mm-hmm. All three legs.
One 1.2. Again, less than 1.5. On the 5-ton Bosch unit, those numbers that we would be looking for is less than 1. Now when Ken's putting the wires back on, we're making sure that the U goes to the U and the W goes to the W and the V goes to the V. Got it all done?
Correct.
Awesome.
Good to go.
Now we can power this unit back up. And what we're going to do now is we're actually going to turn it on. We're going to see what the voltage coming through and to the condenser fan motor will be. And I'm getting these numbers from the service manual. The service manual is a really good depiction of the component itself and what is going to the motor, what it's ohming out to if we want to take the plug away and ohm out the motor, that kind of thing. We're looking at that. So we're going to make a little bit of noise. We're going to move some air when this unit comes on. Remember that I pulled the disconnect, the screen went black, and we are now in a 5.5 minute time delay that we're going to be susceptible to because of the board's delay. It's not a low voltage board. Remember that we do not have a R coming out here. We don't have a power wire coming out here. We don't energize the board through the 24 volt circuitry. We energize and light up the board through the L1 and L2 circuitry. Ken, we've got this unit running. We're now going to go through the system parameter check just like we would in a commissioning or maybe a maintenance or even a service call situation. So right now the machine is running at 35 Hertz. I could push the force button and do the numbers. So let's do that. I'm going to go up here to SW on this particular unit, it's SW1. Now this is a 15 SEER. I'm going to push it, short push. You see the sidewards T, and then it is going to ramp up toward the 100% mark of this particular unit. Fan's going to increase, got a little bit more noise. And what we're looking at here is basically in the installation guide and also the quick start guide, there's always a 25 parameter checklist that I could write down these numbers on this particular one, and that's what we're going to do. All right, this particular unit, it's maxed out, or not maxed out, but at 100%, it's 45 Hertz. I'm going to push SW number 2, which is the check button, short push it one time, and it is going to give me the capacity of this unit. Where is SW6? Where is J2 located? In this particular case, it says H2. So on 0, Ken, let's write down H2. We're going to go through these, and then we're going to talk about them and how they are represented in our product. You'll notice that if I leave it out and not push a button, it's going to go back within the other, the Hertz rating right now every 20 seconds. So I'm going to push it to 0, 1. It's going to give me a 2. Push it again for 0, 2. It is going to give me a 45. 0, 3 is 89. 0, 4, 73. 0, 5, 127. 0, 6 is 3 dashes. We'll talk about those dashes in a second. 0, 7, 76. 0, 8, 96. 0, 9, 116. 10 is 261. 11 is 46. 12 is 39. 13 is 108. 14 is 87. 15 is 37. 16 is 41. 17 is 480, 480. 18 is 11. 19 is 5. 20 is 198. 21, 370, 370. 22 is 14. 23 is H8, Henry 8. 24 is 47. And 25 is dash, dash, dash. Okay? Now, it's as simple as that, doing a maintenance, doing a service call, and if I take these numbers, and again, they mean something, and it would be really great for us to have those numbers in a technical call. It would be great to have those numbers in a maintenance call. It would be great to have those numbers in a commissioning of the unit for the very first time to get a baseline of what this machine is doing. Now, right now we're in the force mode. The force mode would stay there for 2 hours. If I forgot about the force mode and we just left and it's there, it's going to come out automatically in 2 hours. Or if I satisfy the thermostat, killing the Y call, we're back to normal operation. Or when I'm said and done with all of my parameters, my subcooling, my superheat, I can push that button one more time. It goes out of force mode, back into normal mode. We just did it, so that the unit would scale down a little bit and be quieter. Okay? I don't remember what those numbers were, but I'm going to let Ken tell us what those numbers are, what they represent, and tell us about the 3 dashes. Okay. Ken, you're on.
Okay, so the 0 is actually a number when we're going through the parameters on this. So the 0 was an H2. That tells us that it was a heat pump and that it's a 2-ton. The 01 was the number 2. 0 is static or off. 2 is the cooling mode. And 3 would be your heating mode. So that tells us what mode we're in.
So I don't have to have a voltmeter and go between common and yellow to see what's coming into the unit. I could just push a button to 01.
And tell what mode we're calling for, correct.
Wow.
And also when you guys call in on the phone and we're taking, you know, technical calls, just keep in mind when we're going through these parameters, we can see together what exactly everything that's going on here. Number 2 was the outdoor unit compressor speed. So at that particular time, we were in the forced mode. So we know that our compressor was ramped all the way up. The 2-ton ramped all the way up. It was 45 hertz.
So that's 100%.
That's 100%.
Yep.
That's 100% capacity. Number 3 is your T3 outdoor coil sensor. It was showing 89. Now keep in mind, we're in a building here, and you know, so some of these temperatures will be a little different than they would actually be in the field. Number 4 is a T4 outdoor ambient sensor. That's our little ambient sensor that hangs down out of the bottom of our control panel here, giving us outdoor temperature. 5 was compressor discharge temperature. At that time, once again, in the forced mode, we were at 127. Number 6 was double dashes or triple dashes. And on the 15 and 18, that's shown as a reserve. On the 20 SEER, it has an extra sensor that the 15 and the 18 don't have. So if you flip over to the 20 SEER parameters and look at number 6, you're going to see that that extra sensor is a TH compressor suction temperature thermistor that the 15 and the 18 don't have. Number 8 is TF module temperature. When we say module temperature, we're talking about the inverter board or the heat sink board, sometimes referred to as a radiator, but that heat sink big chunk of aluminum that dissipates the heat off the inverter board was showing 96 degrees at that point. Number 9 is the evaporator pressure or PSI. So that's actually your low side. If you were to have your gauges hooked up to it, that would be your low side. It was 116 at that point. And the next one, number 10, is our high side. It was 261. 11, if you remember back when we were talking about dip switches and target temperatures and so on and so forth, that 11 is your cooling target temperature, and it was at 46.
And that represents SW4 number 4?
Correct.
Okay.
Number 4, yes, number
Okay.
4. So once again, when you call in and we see that target temperature, we can tell whether you've manipulated that switch or not to the -4 or lower 4 degrees, or whether it's still at the factory setting. Number 12 was the actual evaporator temperature, was 39. Now, just like 11, 13 is your target temperature for heating. So that's 108. We know that's default out of the box. If you had flipped the SW44, that would show 112, and once again, we would know that you flipped that switch. Number 14 is the actual condensing temperature. It was 87. The 15 is the target of the compressor discharge superheat. That was at 37. Number 16, compressor discharge superheat, 41. Your number 17 is the positioning of your EEV. Now remember, the EEV is only used in the heat cycle. We're metering at the air handler with our TXV during the cooling cycle. We use the EEV for the heating cycle when we reverse the flow of refrigerant and we go to the heating mode. So in the cooling mode, which is what we're in right now, that EEV is going to be wide open, and we're just bypassing flowing straight through it. We're not metering at all from here until we go into the heat cycle. 18 is your fan speed. Well, because we were in the forced mode, this is an 11-speed motor, it was ramped all the way up, and that was 11. Number 19 is your compressor current. That's my amp draw. At that time, at forced mode, ramped up to 45 hertz, this thing was pulling 5 amps, ramped all the way up.
Wow.
Yeah. And on my incoming power on number 20, that's my L1 and L2. It's telling me on number 20 we were getting about 198, 199 volts. Remember, once again, 172 to 270 is our operating range. 198 is within that, and you know, and we're in a kind of a temporary scenario here. Number 21, compressor input DC voltage. That's my voltage going to my U, V, and W. That's feeding that compressor. All of that relates to the hertz, to the capacity, to the load matching, to the demand, the set point, the room temperature. All of this stuff all correlates together. The 22 was continuous run time. So at any time, if the unit is running and you scroll down to number 22, it's going to tell you in minutes how long that system has been running. Now, another little thing that I like about this is if you walk up to the unit and it is static or off, it's not running at all, it's satisfied, or it's not in a either cooling or heating mode. If you go to this number 22, it's not only continuous run time, but it will calculate the off time also. So remember, if the unit is static or off and you go to number 22, it's going to tell you how long that unit has been off.
Wow.
23 is going to be your last fault code. So whatever the last fault code was, it's going to hold it in the memory pretty much infinity until it has another fault code.
Exactly.
Right? So, and then 24 and 25, 24 is a software version. That's not really that important to you guys or whatever. And then 25 is another one that's like number 6 up there that's not actually being used. With all these parameters built into here, I tell my guys all the time, you leave your gauges and your meters and everything in the truck. You get all of the information that you need right here from this inverter board, right off of your digital display. We talked about the Easy Air app at one time, the connected unit. If you were using the connected unit and you did have the Easy Air app on your phone, you would also be able to see all of those parameters with the Bluetooth connected telephone to the board. It's really nice.
So Ken, review in just a little bit.
Yes.
What did you get on number 7?
Number 7 was 76.
What was 14?
14 was 87.
So 76 and 87. Do the math.
11 degrees.
This machine has 11-degree subcooling.
Exactly.
Oh. All I have to do is basically push a button, do a little bit of simple math.
Absolutely.
Superheat, subcooling. What a deal.
Unbelievable.
What
yes.
a deal.
Yep.
Now you notice that our machine has gone back to 74. We've gone back to a flashing light here. That means that's my heartbeat. Remember that I am L1, L2 lighting up the board. But let's see what happened to this unit in that I think we satisfied the thermostat. Let's check it out. Okay. Oh, I don't have to go to my voltmeter. Let's just push a button twice. 1, 2, and look what we have. There's a 0, meaning that I satisfied the thermostat, board went off, air conditioner went off. It is as simple as that.
There's no call at this point.
There's no call.
If it was calling for cooling, once again, it would be a 2. If it was calling for heating, it would be a 3.
Yeah. Let's go down to number 17 and let's look at that number. Because that number that you had on 17 a while ago was 480, is that correct?
Correct. When the system was running in forced cooling and we were bypassing through the EEV, we were wide open at 480.
So when my unit is stagnant, powered up, not running, that number's 360.
So that's just sitting there in a mid position, waiting for the next call.
Absolutely.
What are we gonna do next? We're ready to go.
What are we gonna do?
Are we gonna open all the way up for the cooling mode, or are we gonna start throttling back and metering for the heating mode?
Exactly. Yep. if I was in the heating mode, that number is going to be all over the place, modulating, load matching what's going on, and that's when we get to use the E valve in its fully, what do you call it, operating type situation where it's modulating.
Condition, yes.
There's nothing on the board for you to be scared of. There's voltage, AC, DC, but we saw a while ago how to check the board out, how to verify that we don't have any more stagnant voltage there to be a problem. But anyway, Ken, it's been a pleasure. This is the IDS board. It's awesome.
It is awesome.
Thank you for watching. If you want to learn more about reliable and energy-efficient Bosch products, visit bosch-homecomfort.us.